Good morning, girls. How are you? Okay, today we are starting, inshallah, in our new module 20. Module 20 is talking about triangle congruence criteria. We talked before about, in lesson 18.3, I think, about congruence. Is that when you have two triangles are congruent, for example, then all of the angles are equal and all of the sides are equal. So this is what we are going to be exploring in this lesson. And by the way, lesson 20.1 will be cancelled and we are jumping right away to lesson 20.2. But before we go to our new lesson, of course, we have to do the Are You Ready page. This is in page 988, page 988. Okay, let's think about it. Angle relationships. Again, the alternate interior, the alternate exterior, the corresponding and the vertical and the same side interior. Okay, he's telling you that line AB is parallel to line DC. Find the measure of angle CDE. Where is CDE? CDE. So he's searching for this angle in here. Given that this angle is 33 and this angle is 60. Since these two lines are parallel, can't you think about a relation between this angle needed and this? What is the relation? They are what? They are alternate interior because we have a letter Z in here. There is a letter Z. It's flipped, but there is it. So these two angles are alternate interior. That's why they are going to be equal. Okay, let's see what about measure angle BEC. Where is BEC? BEC. Very easy. How can I find this angle? It's in front of this angle. So these two angles are equal because they are vertically opposite angle. So we are going to write in here, this is 60. Why? Because of the vertical opposite angle theorem. Okay, what about measure angle BAE? Where is BAE? BAE. He is searching for this small angle in here. What is the value of this angle? We didn't note that this angle is 27, by the way. So actually this angle, small angle in here, will be the same as this because again we have the letter Z in here. These two angles are alternate and these two angles are interior. That's why they are alternate interior again, so they are going to be equal. So the angle is 27 by the alternate interior. Okay, okay. Going to question 2, example 2. In example 2, we have two triangles and he is telling you find the length of whatever. Assume that triangle DEF is congruent to triangle GHG. You remember I told you whenever you see these things, you have 6 congruent statements that you can write, which is the first thing we said is we have 3 for the sides. The first side is DE is congruent to GH. Did you see I'm doing this from here, not even from seeing the figure, from here. DE will be equal to GH. So this is the first congruency statement. DE is equal to GH. And EF is congruent to HJ. So in here, EF is congruent to HJ. And then we have DF congruent to GJ. So DF congruent to GJ. So these are the statements for the sides. What about the statements of the angles? We have statements for the angles as well, right? So let's do it. Angle D is equal to angle G. Angle E is equal to angle H, and angle F is equal to angle G. So I have that angle D is equal to angle G, and angle E is equal to angle H, and angle F is equal to angle J. Those are the 6 statements of congruency. Now I can use them to find whatever. Let's read. Find measure angle GHG. He means measure angle H. GHG. How can I find measure angle H? We said that measure angle H is equal to measure angle E, which is 113. So my result in here will be 113. What about find the length of GH? GH is a side, so I'm not going to be looking at the angles, I'm looking here. GH is equal to DE. Where is DE? DE is 16 feet. So it's going to be in here 16. Okay, what about here? If I measure angle FDE, FDE means angle D. FDE, he means angle D, and angle D is equal to angle G, which is 46 degree. So here it's a 46, and then for the last thing, find the length of HG. This is a side, so I'm looking here. HJ is equal to EF, and EF is 32. So here it's a 32. So all of this, to solve this, this is based on writing the 6 statement that we have for a triangle. Of course, why do we have 6 statements? Because in a triangle you have 3 sides and 3 angles. That's why you have 6. But if you are talking about quadrilateral or something, you will be having more because you have 4 angles and 4 sides and so on. Okay. Now let's begin in our new lesson, lesson 20.2. Okay, girls, we are beginning with lesson 20.2, which is called ASA Triangle Congruence, and we are in page 1001. We reached 1000. Okay, before we understand what is this, let me tell you like a note that will summarize the whole module and the next module even for you. Okay, we know that a triangle have 3 sides and 3 angles, right? You know this, we have 3 sides and 3 angles. Let's consider that I have 2 triangles like this. And you were told that these triangles are congruent. We just said in the previous example that if these 2 triangles are congruent, it means what? It means that this side is equal to this side. This side is equal to this side, and this side is equal to this side, right? The 3 sides are equal. If one of them is not equal, are they congruent? No. What else? It means that this angle is equal to this angle, and this angle is equal to this angle, and this angle is equal to this angle. Okay? Which means you have 6 statements, right? Okay, for module 18, you in the questions of in lesson 18.3, the question was always that he is telling you that these 2 triangles are congruent, then find the angle of whatever. For the whole module of 20 and the whole module of 21, you are going to be doing the opposite. You are trying to prove that these 2 triangles are congruent using some theorems. Actually, to prove that 2 triangles are congruent, from the 6 statement that we said, which is 3 sides and 3 angles, you only need 3. If you can prove that the 3 things are equal in both triangles, then the 2 triangles are congruent right away. What are those things I'm talking about? The first thing that you are going to be taking is the name of our lesson, which is the ASA. Let's understand what is an ASA. What is an ASA? ASA theorem. ASA theorem means angle, side, angle. Didn't we say that for congruency, it means that the 3 angles are equal and the 3 sides are equal? Okay, to prove that 2 triangles are congruent, actually, it's enough for you to prove that 2 angles in both triangles are equal and one side is equal. If you can prove that these three things happen, then these two triangles are congruent, then the rest is going to happen. Yani the missing angle will be equal and the missing two sides will be equal. But take care, the name of the theorem actually is not just like haphazard. It's very specific. What do I mean by specific? It's angle first, and then side in the middle, and then angle comes in the end. Which means what? Girls, the thing which is written in between is called included. So here I'm talking about an included side. What do I mean by included side? We have here three angles, right? We have here three angles. 1 and 2 and 3. This side is included between these two angles. And this side is included between these two angles. And this side is included between these two angles. And the same thing is happening here. The same thing is happening here. So ASA theorem, which is required to prove that these two triangles are congruent, is saying if you can prove that this angle is equal to this angle, and then side, so this side is congruent to this side, and then angle, so this angle is congruent to this angle, so these two triangles are congruent. And what will happen when they are congruent? So the missing angle here is equal to this angle, and this side is equal to this side, and this side is equal to this side. Did you see what's happening? This theorem is called angle side angle, ASA. And ASA means what? Angles comes first, and then a side included in between, and then an angle. Yani, for example, if I tell you that this angle is equal to this angle, and this angle is equal to this angle, and this side is equal to this side, is this enough for me? Is this the ASA theorem? No, this is not the ASA theorem. For ASA theorem to happen, the side should be included between the two angles. The side should be included between the two angles. So here, when I tell you, for example, if we name this as angle 1, and this is angle 2, and this is angle 3, and this is 4, and this is 5, and this is 6. Okay, if we name this, for example, and this is like, let's name this A, B, sorry, and C, this is C, and then this is like G, and this is like H, and this is like F. Okay, let's write how the congruency is going to happen. If you can prove that angle 1 is equal to angle 4, and that side AB, because this is the included side, is equal to the included side in the other triangle, which is GH, and angle 2 is equal to angle 5. Oh, did you see? Angle side angle, angle side angle, and here angle side angle. Then these two triangles are congruent. Two triangles are congruent. And what will happen if they are congruent? Since they are congruent, so the other three things will happen, which is what? Which is that measure angle 3 will be equal to angle 6, as well as that the other two sides will be equal, which are B, C will be equal to H, F, and A, C will be equal to G, F, will be equal to GF. Okay, so this is actually lesson 20.2 in a summarized way. This is our lesson. Okay, so let's go back to our book and see what's required from us. Okay, let's jump to page 1003. Explain 1. Deciding whether triangles are congruent using ASA triangle congruence. You can state your findings about whatever as a theorem. This theorem can help you decide whether the two triangles are congruent or not. And of course, since this is a theorem, so you are going to be required to prove it. ASA triangle congruent theorem. If two angles and the included side, as I told you, of one triangle are congruent to two angles and an included side of the another triangle, then the two triangles are congruent. So this is ASA triangle theorem. Take care, by the end, inshallah, of this module and the next module, you will be having more than maybe 4 or 5 theorems. I don't, maybe 4, I think 4, maybe 4. All of them including having these names, ASA, SAS, SSS, HL, something like this. Each one is talking about a certain theorem in which you can prove the congruency between the triangles. So for the first one, ASA. So you have to understand that whenever I tell you ASA theorem, you have to know ASA theorem, I mean two angles and an included side in both triangles are equal, then the two triangles are congruent. Okay, in question 1, example 1, determine whether the two triangles are congruent or no and explain your reasoning. I don't want the answer to be yes, they are congruent and that's it. No, of course not. You have to tell me how did you discover it? Which theorem did you use? Because I'm telling you, this is our first theorem, but at the end you will be having more than one. So you have to tell me I used this theorem to prove that these triangles are congruent. Okay, I have this. And let's see. This is 45, this is 61, and this is 2.3 centimeter. And it's very obvious in triangle ABC that the side AC is included actually between the angle A and the angle C, right? Okay, let's go to the other triangle. First of all, 61 is equal to 61. Very good. The 74 is something not here, and the side DF is actually not included between the two angles. So can I use the ASA theorem? For now, no, I can't use it. What should I do? If this angle was known, then this side will be included between these two angles, right? How can I find measure angle D? Very easy. Whenever I have a triangle, the three angles together form a 180 degree, right? It means that measure angle D plus measure angle E plus measure angle F is 180. Angle D is unknown, so plus 74 plus 61 equal 180. Adding them together 135, and then what should I do? Shift 135 to the other side. I found measure angle D to be 45. So the angle in here now is 45. This is now here, this is 45. Now let's begin comparing. Angle A or angle side angle. Angle side angle. Are they equal? Yes, they are equal. So measure angle A equal measure angle D equal 45. AC equal DF equal 2.3, and this is an included side between the two angles. And measure angle C equal measure angle F. So I can write that triangle ABC is congruent to triangle EF by the ASA triangle congruency theorem. We prove that these two triangles are congruent using the ASA triangle congruency theorem. Okay, let's do question B together in here. Okay, find measure angle, no, sorry, just read the question. In the question, we have J, K, L, and M, P, N. And as you can see in here, I have angle, side, angle. So this triangle is ready. But in here, I have angle, angle, side. So no. So the result for me is to find measure angle P, right? So let's find measure angle P. Let's find measure angle P. Again, how can I find measure angle P? We said that measure angle N plus P should be 180 because this is a triangle, right? So M is what? M is 38. So here, this is 38. Plus N is, yes, I missed them. At the end they are going to be added. 31 should be in here and 38 should be in here because measure angle M is 31. But in the end it's going to be added, so it's not of a big deal. Okay, anyway, and then you are going to add them together. This will give you a what? This will give you 38 plus 31, I think 69 degree. Yes, 38 plus 31, yes, 69. So here it's going to be a 69. And then how can I find P? Let's shift 69 with a negative sign to the other side. So measure angle P is going to be 180 minus 69, which is going to be 111. 111. 111. So the angle here is 111. Okay, let's compare. Measure angle J is equal to measure angle M. The side included is equal to the side included. And suddenly, is measure angle L equal to measure angle P? No, there isn't. Are they equal? No, they aren't. They are not equal. Since they are not equal, so is these two triangles congruent? Actually, they are not congruent, which means, is there a sequence of rigid motion? You remember the rigid motion? If there were a sequence of rigid motion that can change one figure to the other, then they are congruent. But if there isn't a sequence of rigid motion, so they are not congruent. So here, none of the angles has a measure of 1, 1, 1, the things we got. This is a very, very strange angle. Therefore, there is not a sequence of rigid motion that maps triangle MNP onto triangle GKL, and triangle MNP is not congruent to JKL. Right? Okay. For question 4, in part B, do you need to find measure angle K? Do we need to find it? Actually, no, because already they are not congruent. Of course, no, we don't need, because they are already not congruent. Okay? Okay. Let's clear. And then let's go to the next page. Okay, I will solve with you question 5, and then you can do 6 on your own. Determine whether the triangles are congruent or no, and explain your reasoning. And as you can see in here, he is telling me that this is equal to this, and that this is 90 degrees. Does this remind you with any theorem we took in module 19? We have two lines intersecting together, and this line is perpendicular on BC and bisecting BC. So this is a what? This is a perpendicular bisector. You remember? This is a perpendicular bisector, right? Okay. And this is 90. So according to our theorems of the perpendicular and the 90 degrees, so this angle also is 90. So these two angles are 90. So here we can say that this is 90 as well. And since he did this mark for you girls, so he means that this angle is equal to this angle. If, for example, you found him doing like this, yani here you have two marks and here you have one mark, then these two angles are not congruent. But since he did like one mark in here and one mark in here, so he is telling you that these two angles are congruent. Okay, let's investigate. Angle, side, angle. Angle, side, angle. Angle B is equal to angle C. And then the side is equal to the side, and then angle D is equal to angle D. So are they congruent? Yes, they are congruent using the ASA theorem. So we are going to write in here, angle B is equal to angle C. And then side BD is equal to side DC. And then angle ADB is equal to angle ADC. So using ASA theorem, these two triangles are congruent. Very easy, right? Okay, you are required to do question 6 in the same way. Tell me, are they congruent or no? Of course, you have to find the missing angle in here or in here. I think in here. Okay, try to think. Okay, let's go to the second part of the lesson. Okay, in the second part, we are doing the proof that you love about the statements and reasons. The ASA triangle congruent theorem may be used as a reason in a proof, as a reason, girls, as a reason in the reason column. Yani you remember when we used to write, for example, using the alternative, using the same side postulate, using the substitution property of equality, using whatever, definition of supplementary. You can use the ASA theorem as a reason when you are trying to prove. Let's see question A. Given that angle, take care, there is a difference between this sign in here, and this sign. What is the difference between both of them? Is MQP. So what is the difference between this and this? Here he is telling you angle MQP, but here he is telling you triangle MQP as a whole. So take care. So here he is telling me angle MQP. Where is MQP? MQP, this thing in here, is equal to NPQ, this thing in here. Okay, let's make a mark. Yani he is saying that this angle is equal to this angle. And then angle MPQ, where is MPQ? MPQ is equal to angle NQP. So these two angles are equal. So let's do it in another color. So this is equal to this. Okay? The required to prove is prove that the two triangles are congruent. Till now, we already took one theorem, which is ASA. So to prove that the two triangles are congruent, I need to prove that two angles are equal and the included side are equal. Let's think before we write anything. Here you have already two angles equal. This is given, that this angle is equal to this and this angle is equal to this. And the two angles, what is the side included between them? Yani, is it enough for me to prove, for example, that these two sides are equal? No, I have to find an included side. And where is your included side? It is this one. And take care that this side is included between the upper angles and the lower angles. Yani it's one side. So since it's one side included in both angles, but is it equal? Yes, QP is the same as QP, right? It is the same. QP is equal to QP. So I can prove that I have two angles equal and the included side is the same, it's equal. So these two triangles are congruent. Okay, let's read how to do it. To do it, you are going first of all to write the givens, right? So the first given and the second given, and then the two angles are already given. So I still have to state the side. So QP is equal to QP because it is the same. And this is called the reflexive property of congruence. You remember the table of the properties of congruency? You remember the transitive property and the reflexive property. You are going to be using the reflexive property. Reflexive property is when you say that something is equal to itself. 1 is equal to 1, 2 is equal to 2, A is equal to A, B is equal to B. This is called the reflexive property of congruency. So here, QP is equal to QP. This is the reflexive property of congruency. Since I have two angles and one included side, so I can say that these two triangles are congruent using the ASA triangle congruency theorem. Okay? Okay. Let me do question B with you as well. Let's read question B before we write anything. Given that angle A is equal to angle C, let's angle A is equal to angle C. And E is the midpoint of AC. E is the midpoint of AC. He means what? He means that this side is equal to this side, right? Okay. He wants to prove that these two triangles are equal. Let's think. Till now, we already took one theorem, ASA. So I'm trying to prove that two angles and an included side is equal in both triangles. He already told me that angle A is equal to angle C and that this side is equal to this side. So which angle should I use? Is D going to be important for me? We said no, it should be an angle, the side should be included between them. So this angle E and E, so that I will be having angle, side, angle, and here I have angle, side, angle. So let's think, is angle E from both sides equal? Of course they are equal because you have a giant X in here. So of course they are equal using the vertically angled theorem, using the vertical angle theorem. So I can prove that two angles and one included side are equal. So using the ASA theorem, I can say that the two triangles are going to be congruent. Okay, let's begin writing. First of all, angle A equal angle C, this is what this is given. E is the midpoint of AC, again, this is what this is given again. So AE equals CE. This is what? This is the definition of what? Definition of midpoint. This is the definition of midpoint. Okay, very well. Angle AEB is equal to angle CED. Angle AEB is equal to CED. Why? Why these two angles are congruent? Because of the vertical angle theorem. So triangle AEB is equal to triangle CAD. We're using the what? Using the name of our lesson, ASA angle, ASA triangle theorem, triangle congruency theorem. Let me know the name exactly. Why did I miss the name? I think ASA triangle theorem is. Yes, ASA triangle congruency theorem. So in here, ASA triangle congruency theorem. Okay. I think actually it's fun. We have a lot of theorems now and we have a lot of reasons to think about. Actually, the proving in geometry is not bad. This is very, very fun. But try to practice a lot in it. Okay, anyway, inshallah, I will leave for you question 8 and question 9. Try to do it. And I will do tomorrow, inshallah, for the first period. I will do 8 and 9 with you as well as some extra examples in the evaluate section. And then we will be having our online session in which I will be answering any of your questions. Okay? Thank you and see you tomorrow, inshallah.